Hi friend, today I am going to discuss about what is RSRP, why power and RSRP value in negative, what is dB and dBm. This is a small point, but we should understand to clear our concept. First of all, we need to understand RSRP. RSRP stand for reference signal received power. Reference signal received power is calculated on the basis of suppose E node B sending a reference signal that what power is used for sending the reference signal from the E node B to the mobile network, and what power that reference signal is received on UV side. This is the ratio is called RSRP, and RSRP is calculated on the basis of RE. Suppose one RE where a reference signal is placed. But RSSI, if we discuss RSSI, is measured the power uh, entire bandwidth from entire bandwidth. So also we can calculated RSRP always calculated from the on the basis of RSSI. So RSRP is the calculating from the RSSI. This is the formula. N is here N is RE across RSSI measured and depend upon bandwidth. Suppose 5 mega band 5 megahertz bandwidth, 10 megahertz bit. So have different in value. So we can calculate RSRP from here, but we take directly taking example to understand the RSRP. So suppose input power means E node B sending uh, used in that power to send a reference signal, and at the UV side, UV received a reference signal that time what power UV received. So RSRP, we simply say that output divided by input power. So yeah, first of all we should understand what is dB and dBm. dB dB means decibel. If power is calculated in decibels, decibel is a unit to calculate the power, and this decibel is used to calculate. That means if we decibel is in negative, because this is the form of log, yeah, log and their value. So if we taking, that means we got a negative value. So and dBm, what is dBm? dBm is power is measured in decibel, but reference to 1 milliwatt. That means input is suppose 1 milliwatts, and output what the output received. So if we calculated uh, taking reference to 1 milliwatt is called dBm. So RSRP we saw dBm. That means we taking uh, as input power is 1 milliwatt for the reference. So this is the formula to convert our simple power into the decibel to measured reference to the 1 milliwatt. If 1 milliwatt, so this 1 milliwatt I am we take suppose yeah, if we is simple formula, if we converting in dB, so we convert 10 into log into output power divided by input power. If RSRP in dBm, if we dBm taking, that means input power is 1 milliwatt. So 1 milliwatt. So we I am going to show you some example. So here RSRP is 10 into log output power, power in a watt or divided by 1 milliwatt. So suppose we can take also here in milliwatt, because both will same, so we can divide easily unit. So here we are taking, suppose output power, we are output power is 1 milliwatt, and input power also here 1 milliwatt. So dividing is equal to 1, and log 1 is equal to 0, so 0 dBm. Suppose yeah, output power is equal to zero point 0 milliwatt, so is equal to yeah, minus 10 dBm. So if we put here input what we receive, then after that UV will calculate RSRP value in negative, because he received the output power just, and there yeah, in script they inbuilt the formula in UV side, so they are put here and will calculate. So here I am showing you some example and taking some output power. So here if we take output power is 0.9 times 0.1, after that we got minus 100 dBm. So this is the formula. So we can see here, if we getting, suppose I am taking example, because if we uh, yeah, yeah, dividing by 10, so dividing by 10, so if we got minus 10 dB difference, so it's easy, so that's why we take example. But we got here 1 dB, 2 dB, 21 dB on the basis of power what they receive, and calculated on this firm on the basis of this formula. So so I think you understand. So uh, I am going to take one simple example also to understand the power. Suppose power, you see, if we see in the power, you got power is positive also and the negative also, because here we can see the formula. If the one is the milliwatt, if we taking below power is coming is the good for one below 1 milliwatt. So suppose we got a negative value, so we already seen here how can we get negative. But if we taking more than the um, more than 1 dB, sorry, more than yeah, 1 milliwatt, so we got in a positive if we power is used more than the yeah, 1 milliwatt. So suppose if here we use 10 milliwatt. So if we calculating in dB, power in dB is equal to 10 into log, if we converting, so here 10 milliwatt barabar divide by 1 milliwatt is equal to 10. So suppose 10 into log 10 is 1, so we got a 10 dBm, 10 dBm here in a positive. If we yeah, positive value if we use, so if we use 2 milliwatt. So I think you understand. So finally, we can this is the shortcut formula. So I think you sometime you heard about minus 3 dBm loss. So minus 3 dBm loss means power is so suppose yeah, power is sending by E node B and UV received half power. So 3 dBm loss. If we gain 3 dBm, that means power is double. And if yeah, power is multiplied by 10, that means 10 dBm. So it's yeah, very yeah, easy to understand and calculate. So that time also always we calculated on the uh, yeah, basis of 3 dB, 3 dB, 6 dB, minus 3 dB, minus 6 dB is easy to calculate. That's why we all use always in a 3 dB, minus 3 dB, 3 dB. So I think this is also used for power management. This concept will use to power management. So I think you understand, but power management I will come with another video. So thank you.